do my best not to have a panic attack. And you folks, please pretend to laugh at my jokes. Just like that. OK. So who's this guy? First off, I really debated on whether I should blur that out or not, and I opted for the sake of the audience to blur that out. Hopefully you get the intentional meaning. If you check the slides online, it's got the profane version, which I know is some serious profanity. So I'm Phil Corliss. You can find me on most social media as P. Corliss. Feel free to reach out if you want to get in touch. I'm happy to answer questions about anything and everything. A little bit about me. I started my career as a sysadmin before the term DevOps was a thing. I racked a lot of servers. I own a punch-down tool. I have a fairly nice ratcheting crimper. It's excellent. Highly recommend the brand. I wrote a lot of Perl. I did a lot of automation. I carried an old-school pager. And about 5 years ago, I made a transition to software development. I started building a lot of consumer product. Suddenly, I stopped writing Perl, and I started writing Ruby and JavaScript and CSS. And I started making web forms, and I started tweaking things and moving things over by just a pixel. And I learned the difference between a serif and a sans serif font. So just out of curiosity, who knows what a sans serif font is? Oh, man, I thought I was the only one. You guys are really good. So along the way, I learned one or two things about making customer-focused products. I learned that you should start from the customer and you should work your way backwards. That's a phrase from, I believe, imported from Amazon, eventually to Groupon, which is coincidentally a place where I worked. And along the way, I kind of started out doing very consumer-focused product development, and then I kind of started moving back towards my sysadmin roots, and I kind of fell somewhere in the middle, building tools that helped configuration and service management and that sort of stuff. And so I learned a few things along the way, and I want to tell you about those things during this talk. That being said, I'm based out of Chicago. I used to work at Groupon, and now I work for a great company called Braintree Payments. Who here's heard of Braintree Payments before? Yes, all right. So Braintree Payments is awesome. And if you have payment needs, you should definitely reach out to Braintree Payments. Getbraintree.com. That being said, my opinions are my own. They are not my employers, former employers, or future employers. So what are we talking about when we talk about developer happiness? Am I talking about software developer happiness? Am I talking about sysadmin happiness? Am I talking about DevOps happiness? Am I talking about QA or product or business? Whose happiness am I actually talking about? And the answer is super hand-wavy. I'm talking about everybody's happiness. So theoretically, the technical team is happy because things work with a minimum of hassle, and the business is happy because everyone else is happy and things are staying up and alive. That's the goal. The goal is everyone's happy. Everyone's uniquely suited to enjoy this beautiful land of unicorns and rainbows. Personally, I'm happy when things are clear, things are easy, and we're not wasting time. And then when my coworkers are unhappy, I end up being unhappy because I internalize their frustration. So I've got a lot of empathy for the folks I work with. So that's what I say. That's what I mean when I say happiness. There's a lack of frustration along with high productivity at the very basic level. So you folks look really happy right now. Is that a fair assessment? No? OK. I'll try harder. And so when we talk of happiness, I'm sure everyone's mind immediately wanders to big companies, right? You think happiness and working at a big company. Those two are interchangeable. They're linked right there. When I started at Groupon, just to give you an idea of the sort of happiness at a big company, I started at Groupon, there were 50 people in engineering, which is already a fairly large engineering department. When I started, my starting class of all the people hired that day was 150 people. I had never worked for a company with 150 people before, let alone started at a company with 150 people starting that day, including customer service, sales, business, and everybody in between. So that was a big shock. I started working there. I was there for 3 years. I got promoted several times. I was a software engineer, and then I was a technical lead, and then I was eventually an engineering manager. And then I left. I won't tell you why, because that's secret. It's not secret. But when I did leave, there were roughly 800 engineers, give or take a few hundred. And you might be wondering, how can he not know how many engineers there were at the company? And I'll tell you, it's really hard when there's 800 engineers, give or take a few hundred, to figure out just how many engineers work for your organization. The closest thing I could get to was the number of counts in GitHub Enterprise. So kind of difficult. So taking a step back, like Groupon and other big companies are not like inherently bad. You know, they're just big companies. They're a natural organism that arrives when you get so many people all going towards a common goal, which is, you know, increasing shareholder value. And suddenly you get competing interests and everyone's getting paid and like suddenly like the salaries matter and like things conflict and it's hard to reach that you know, common interest, which is getting your service delivered and making sure it works and it works on time. So internally, you get a lot of strife and a lot of conflict. But it's just kind of a natural thing that happens, not because the big company exists. But like inside that big company, you've got like these things that are always changing. You've got like constant process coming down the pipeline. You know, this is new, and that's new, and this is new, and they're all competing for your eyesight and your vision at that given point in time. That's hard to work with. Like it's that constant change and churn is like a serious tax on your time and your focus. So out of curiosity, big company, get big company pride. Who here works for a company, say, listed on a public stock exchange? Yeah. So you guys know exactly what I'm talking about, right? No? Yes? All right. Okay. You guys are awake. I'm sorry. It's after lunch. I'm getting kind of sleepy too. So, you know, inside these big companies, you're going to have lots and lots of tools. With 800 engineers, you're going to have a few tools, maybe a few, one or two, right? Like eventually some automation is going to come in. And those tools are going to be big, they're going to be small, they're going to be everywhere in between, and they're not going to be entirely discoverable. And then this is my favorite kind of caveat at working at a big company. When you break something, you just broke it for 1,000 people across your organization. Or you broke it for the person that's about to wake up in Dublin at 4 a.m. your time. Or you broke it for the person that sits 10 feet away from you. Maybe you just forgot a where clause on a delete statement in SQL, or maybe you did something far more innocuous. I'm not saying I've ever done that in a production system live, but you know, it happens, right? Like we all know how that goes. But my point being is that like engineering in a big org is hard. It gets even harder when you want to change things, and it gets even harder when you like have to force that change through. So we're going to talk a little bit about like how that works and how that happens. And that's not to say that these same problems oftentimes don't exist in small orgs. I feel like they're just amplified by like multiple orders of magnitude in the big orgs. So let's say you do want to fix something. What do you do, right? Well, you get to navigate institutional barriers. Inside these big orgs, there's like an inherent fear of change that develops. Tiny, small things potentially set off butterfly effect-like reactions throughout the rest of the organic system that is your big company's processing and data. And then suddenly all this interconnected stuff, like something breaks over here, and Tim and marketing and Jan and accounting suddenly don't have access to a very important metric that was absolutely required to do their job 5 minutes ago. Those tiny little changes create this fear of change. So you can't like operate in an environment where there's a fear of change, because you have to quantify that change to every stakeholder in your business. And then you have to explain to them how that little itty bitty change that you want to do isn't going to affect them in a negative way. And then you don't necessarily know if it will or won't. There's also this kind of weird thing that happens when you want to replace something. You can't ever replace something with half the features, right? You guys, okay, I heard a couple of chuckles, and you know what I'm talking about. Like if you have, you know, service A, right, and service A does these 10 different things. If you try to replace it with service B, and service B only does half those things, even though it does it really well and in a maintainable way, and it's highly available, and it's scalable, and it's cheap, you can't do it, right? Because someone else in your organization uses that obscure little feature that's attached to service A. And you can't change it until you've done everything, right? And so this is why like rewrites typically have a chance of failing that are really high, right? It's really hard to get a rewrite working. And that's because if you don't reach feature parity, you're not going to be able to replace something. And if you can't get to feature parity, you know, you're in a bad spot. So emotional investment plays a part. Like I don't want to like drop my feature. I'm not going to let you replace my service if it's used by lots of people and I've got my heart and soul wrapped up into the last 5 years of work on it. So you'll get like these internal people that they don't want you to get rid of their service because their service is important to them and it should be important to you. And like those things all kind of like mash together into this big, slow-moving, inertia-driven organization. And so I'm going to talk about how we went about trying to replace one particular product in an organization that shall remain nameless, which we technically just kind of like papered over the top of it to make it better. So I'm not going to name this service, and to protect the innocent, I'm just going to call this tool Airplane. This Airplane was essentially like this homegrown configuration, authorization, package management tool that did absolutely everything. And some of you may see where this is going. Others may think, hey, that sounds pretty cool. Where can I get this? So like, let me tell you a little bit about it. The base was a Git repository containing a bunch of readable YAML files, a few thousand readable YAML files that described the production infrastructure, staging infrastructure, QA infrastructure, and development infrastructure. You might be thinking 1,000 YAML files, that sounds good, or that sounds bad. I'm curious. But you edited them, you committed them, you uploaded them, and then that informed the rest of the structure. Okay, it doesn't sound so bad. There was a bunch of custom code in it to interpret those files. And so like on boot or on reload, like a machine would read those files, interpret them, and then that would define how the machine came up in an idempotent way, so to speak. So like, okay, that doesn't sound so reasonable. Like it got its packages, it's got its users, it's got its networking configuration, it started things up. Okay, that sounds pretty reasonable. So you could update things when you need it. There were like 20 or 30 scripts checked into the Git repository that allowed you to like add yourself to a box or change a package or upgrade this across the enterprise or do a variety of different things. Okay, we had a bunch of command line tools. It sounds good. And then there was like, this is the best part, and this blew my mind. There's 20 pages of documentation for this tool. So 20 pages of documentation is amazing, right? No one writes documentation except for this guy who wrote a ton of documentation for the tool. And like every feature switch and every argument was documented, and I was like, holy smokes, this is the best. It's got a ton of documentation. And then here's the kicker, right? Like this thing was stable. It did what it was supposed to do. It did it every time. Like there was a few bugs every now and again, but we fixed them. Like this tool did what it was supposed to do. And so right now you're saying, whoa, hold on, you screwed up your title, right? Like here's a stable tool that like has a bunch of documentation. It's got all these like scripts and automation around it, and it's just readable YAML and a Git repository. That's something I can handle. And that's not quite how it went, right? So like Airplane was a really good engineering effort done by some really smart people. But at the end of the day, people hated working with Airplane. It was terrible because it created tons of frustration. There were all sorts of little problems in working with it that we kind of forgot about because it was stable and it did the right things. And like there was tons of complexity and yak shaving just to get your work done. So if you can't get your work done, you're going to get angry. Who here can't get their work done sometimes and then gets angry? This guy with 2 hands, right? Like, all right, so we've got a few people. Apparently the rest of you are asleep. That's fine. I had a rough night last night too. So let's talk about why, like what was going on there. So multiple compound commands in order to get anything done. So you ran that script to authorize yourself on a host. And then you ran another script to add a package, and you ran another script to, I don't know, put the foo service and the bee service and hip bones and all that good stuff. So that you did that, then maybe you edited something manually with Vim, you ran git add, then you ran git commit, you put a commit message in, then you ran git push, but oh no, it errored out because there's a change since then, so you've got a fast forwarding error, so you git pull rebase, and then you do a git push, and then it's up. And then you get to run a third command to actually like start the change. So like all of that work just to make a change in your production infrastructure and then to roll out that change in the production infrastructure. Some of you might be saying, that sounds pretty good right now. Others might be saying, that sounds absolutely crazy. I'm of the mind that this sounds absolutely crazy. That's too much work. So I like less work because I'm lazy. Who's lazy? All right, my people. So some of the things that people didn't like, Git, like non-technical folks, they didn't understand Git. They didn't want to understand Git. They just wanted to get their job done. Technical folks that were new to Git or version control in the Git style, they didn't like it because they couldn't get their stuff done. There was weird merge conflicts every now and again that they couldn't work their way through. Also, Git has this kind of weird thing where high latency connections do not work well with large repositories with lots and lots of tags, heads. If you end up with a high latency link, that actually fails pretty miserably in terms of doing updates for lots of changes. And like, there was also like this weird system where like you would do a git pull rebase, ampersand, ampersand, git push. And so for those not in the know, that does a pull rebase, takes your changes, puts them on top, and then immediately pushes out on success of that command. That would sometimes fail. And the reason it would fail is because other changes were coming into the system so fast that in between the pull rebase and your git push operation, a new change was coming in, which is bonkers, right? Like, that sucks. So we actually had another command that would just run pull rebase and git push until it succeeded, right? Because what are you going to do, right? I think it was like called like git retry or something. It was terrible. So like the 20 pages of documents, like that seems nice until you think to yourself, who's going to read 20 pages of documentation? Who here has read 20 pages of documentation for something? That, oh, you guys are, I thought, yeah, in anger, okay. That's what I'm saying, right? So like, until you like run into a problem, you're not going to read the documentation. You're not going to read the documentation when you're brand new. You're not going to, internalize that documentation and then remember it 4 weeks later when you get to use this tool again. So like, this 20 pages of documentation was so long and so large that we actually couldn't even internalize it. The tool was so big and complex. There was so much going on, so much documentation, you couldn't wrap your head around it. You couldn't keep it in mind, keep it in your head. I worked on the tool. I have commits in the tool. I don't remember how the tool works because it's a big tool. These things are hard, right? Engineering is hard. Software is hard. All right. The YAML. YAML's I love YAML. A readable markup language is great. It's great for configuring things. I love it. Except when you implement a custom parser that alphabetizes your hash keys and your arrays. Never change the order of an array. Just throwing that out there. You can change the order of a hash, but don't implement a custom parser. Just please do me that favor. And then folks in the know may know that package management is kind of a hard problem that like various distros are solving. Don't re-implement package management. I can guarantee you that you're not going to do it right. So this particular tool, Airplane, did not implement package management all that well. And then the last bit, and this was really important to me, I started at this company as a software developer. It didn't understand the concept of a rolling deploy or a zero downtime deploy. So that's kind of a big deal when you have to develop highly available services. So we had to manually like push out these changes. So what did we do? I don't know, man. I'm still trying to figure that out. No, I'm just kidding. We did figure something out. We got buy-in to do some more work. And basically, we got buy-in to wrap the outer layer of it. So instead of like getting rid of it entirely, we put a layer over the top so that you wouldn't have to work with the current interface anymore. And we're going to go into that in just 1 second as I get my slides back in order. OK. So we had to internalize this stuff before we could be a few things before we could be successful. So gatekeepers, right? I saw a few talks talking about gatekeepers. And when I say gatekeepers, and some of you are probably gatekeepers, so this might be a little bit of blasphemy. Don't kill me. No rotten vegetables in the theater. They said no food's allowed. So I can't stand gatekeepers. Gatekeepers get in my way. Gatekeepers stand in front of me getting my work done. Gatekeepers are there to like hold the locks and like to hold the keys to the castle, and they're not going to let you in until you satisfy their demands. You don't want to be a gatekeeper. You don't want to be that person that has to grant access to the QA box. You don't want to be that person to grant access to the staging box. Being a gatekeeper means that you're actively preventing someone from doing their job. Your sole purpose in life as a gatekeeper is to push frustration onto someone else, right? It's not to keep things up, right? It's not to keep things available. It's to push that frustration onto someone else. That's not true. We're all good people here. We're not, what's that? Oh, I don't know, man. So we're all good people here, but like we're not actively pushing frustration, but we forget that the person on the other end of the screen is actively trying to get their job done. And by being a gatekeeper, we're blocking them from doing that. Also, I don't know if you've ever been on call at 4 in the morning when Dublin starts, but the Dublin office starts at 4 a.m. your time, and guess what? They need access, right? You don't want to be on call. If you're ever a gatekeeper and you're thinking, people talk to me at 9 to 5, that's not going to be true when the Dublin office opens. So keep that in mind. And it's scary. It's really scary at first. Like, you know, people need to get their work done, but you also need to keep things up. So like, I don't want anyone to do malicious things, so I better block them from doing it. And you can minimize potential damage from the malicious and the ignorant folks by just keeping in mind that there's always audit trails. You can always put an audit trail in. You can put in intelligent limitations. So like, hey, just a quick warning, a double dare. Do you really need access to prod for this? Maybe you should reach out to the person on call, or you can influence culture by saying like, hey, prod is a dangerous place. Put that on the message of the day for your prod boxes. Don't do stupid stuff in here. Put double dares everywhere. You can put those things in front of people that make them second guess their original notion, which was to run that delete statement in prod without the where clause. True story. All right, so what else did we do? Automation and process, right? So those two things are inexplicably linked. So my definition of process, which may or may not be the same as yours, is processes are human-centric operations, and they rely on one or more people following steps one by one in perfect order and without mistakes. Okay, so automation is computer-centric. It relies on computers following steps one by one in perfect order and without mistakes. Perhaps you saw some of the similarities in what I just said. It was supposed to be a joke, and I only heard a few chuckles, so there we go. Yeah, okay. Process, like the logical conclusion of process is just automation at the end of the day. So why would we implement a human-centric process when we can instead implement a computer-driven process? I saw earlier in an Ignite talk that someone didn't want to do more automation, or they didn't want to automate everything, just the important stuff, and I agree. Sometimes the human-centric process is like a test case before you get to an automated process. I'm a big fan that when someone comes up to you and says, hey, like this is a request for comment for a new human-centric process, you say, why don't we just automate this instead of getting everyone to follow the same steps in lockstep. At the end of the day, you don't want someone typing cap QA deploy. You want it automatically going to QA after your Jenkins build passes. So I don't know if you guys have ever run this command. I had the opportunity to run this command 2 days ago. In Ubuntu 14.04, this command outputs 1076, which is the number of lines in the find man file. That's a lot of documentation, right? We talked about documentation before, but in general, like a command line tool with 1076 lines of manual entries is not something that you're going to be able to read, understand, and like conceptualize and internalize. I've used find for a long time now. I'm pretty good at a command line. Maybe you are too. I've never used all the switches. Who here's used all the switches of find? Oh, a couple of hecklers. Okay. So like the man page is there, like all these awesome things are there, the command line tools are there, but they're really hard to use, right? Because you're never going to know everything there is to know about it. It does what it does, but only because it's ingrained into what you know in your muscle memory. They're hard to get right, they're hard to build, they're hard to update. Portability is a pain, with the exception of maybe like Go or Python in some instances. You have to distribute your credentials out to everybody. There's internet connection and latency issues, which we talked about with Git. They're hard to use. Maybe you don't agree with me here, but like they can be really hard to use. Generally, like with engineering departments, they believe that like the developer is most comfortable on the command line, or the operations department is most comfortable on the command line, and I wholeheartedly disagree with that. Turns out we're all human beings here, and the command line is a hard to interpret, hard to work with tool. And so what else do you do instead? Oh, I'm so glad this worked. So you build web GUIs, right? And you might be thinking, Phil, this is a pretty lame lead up to web GUIs. I could have told you that we could build web GUIs earlier on, and I'd say, well, then what would be the point of this talk? Couple of chuckles, more chuckles. Okay, so there's a lot going on here, and some of it may seem obvious. This is a mock-up of something that we did with Airplane when we wrapped Airplane. This is around something simple like user authentication on our servers. Just let's get some server access, let's add a couple of people to it, let's hit save, and let's go. Like, this is easy, right? And we all know conceptually in the back of our head that this is probably easier than running a script to add yourself to a box and then puppeting out the box, you know, calling Chef Solo or doing whatever. But the nice thing about this is you can think about what we're actually looking at here. You're seeing autocomplete that prevents typos. You're seeing the ability to select multiple servers all at once. You're seeing multiple users added. Like, this is not like rocket science, you know? This is just a simple web form. And we can do this. We can build these things. They're not that hard, right? And all we have to do, and like when you finish building this, you've exposed an API which can then be used and leveraged by other tools within your environment that don't require like the runtime of this other disparate tool set. Now it's just an API, and it can talk over JSON, HTTP, and be good to go. So in addition, you get some nice valid feedback. You can inform the user. You can tell them what they're doing right, what they're doing wrong. And it provides a very clear, simple user experience. I don't think anyone would like go to this and say, what's a server and what's a user? And if they are, maybe they're the wrong audience for it. But most people are going to look at this and they're going to say, oh, I'm going to pre-populate. It's pre-populated my name in here already. It's saying give me myself sudo access. I can type in the servers I need access to and hit go. Like, these are all things that we can do. And we can make this more complicated. We can add more numbers up and down the side to have like longer processes that require more automated steps. And I personally think that this is a much better user experience than the command line tools that we're normally used to, unless you happen to know the command line tools. Now, that being said, your intern's going to come in. Your intern's going to love this. Your senior architect's going to come in, and they're going to at least know how it works, and they're going to be able to use it. Everyone should be able to use this. For folks in PCI or SOX scope, you may still need that gatekeeper per your SOX regulations or whatever, but I will tell you this, that the people responsible for clicking approve 500 times in a day would much rather have a web GUI where they can bulk approve 30-odd people than they are to type the commands necessary or pipe something into Xargs out of a CSV. So, last but not least, documentation. 20 pages of documentation seems excessive. We took a very low documentation approach. So like the README, we had a README that just told us how we could run our tests. We had a README that told us how to do local development. We had API documentation around what the API endpoints were, the very bare minimum to get a project off the ground. And then we relied on those easy user experiences to inform the user how they should use the product. You don't need a lot of documentation when your interface is so simple. So just a quick summary of the things we did. All 4 of those things, or I guess there's 5 of those things. Hey, counting, off by 1 errors. Chuckles, all right. We eliminated the gatekeepers. We replaced process with automation. We ditched the command line. We used web GUIs instead. And then we got rid of our documentation. And so how do we do? Are people happy? So the answer, and I wouldn't be giving this talk otherwise if the project wasn't wildly successful. We basically built we built a whole suite of GUIs, all centrally located from a standard place that removed the need to use the command line tool throughout our system. We built these GUIs. They were easy to use. People didn't need to know how to use Git to use them. They didn't need to know how to use the command line tools. They didn't need to know how our services worked in order to get going and get moving and be productive in their jobs. And within a few months, everyone was using it over the command line tools. And we were almost at like 90% feature parity with the original stuff. Over time, the hope was to get to 100% feature parity and then eventually remove the system underneath it entirely, but maintain that front-facing API. So, but overall, like that big win was making folks happy by just improving the user experience. Because it turns out that your users, the people that are internal to your organization, are just as important as the people external to your organization. The customers that buy your widgets and buy your widgets and buy your bathtubs and buy your soap dispensers, they're just as important as the ones that sit 10 feet away from you and need help using the tools that you build. So why don't we build tools to make those folks happy as well? So I'm Phil Corliss. Big thanks to the organizers for having me. Big thanks to Braintree, who are providing my lodging and airfare. They're hiring, so please reach out if you have any questions about them. And a big thanks to all of you folks for sitting so patiently throughout my talk.
All right, guys. Thanks, Philip. So we're going to take some questions for Philip. Any questions? No questions. Right over there.
We do not have an office in Toronto. We have been known to hire a few remote folks. If you're interested, please reach out and maybe we can find a match.
Hey, one of the things that you did was you rightly made a nice web UI to all of to all the things that you wanted to automate. I'm just wondering if some of the people in your organization, airplane organization, who are really familiar with the shell and they're like, yeah, I can hack anything together. If they're wondering, how do I compose these tools?
Yeah, it's definitely a skill. It's definitely like a skill that not all back-end developers have when it comes to developing software, right? If my tool set, my toolbox includes writing, I know how to write an option parser in Python and Ruby, but I don't know how to use select2 to do like the autocomplete stuff that I showed off in that little demo. Like that's a definite like skill mismatch. That being said, I'm a back-end developer who suddenly was forced into like the front-end development experience, and I'm not the smartest person in the room. It took me a little while to figure these things out, but you can figure these things out. And I think we owe it to our internal customers to give them the best experience possible. So maybe your first effort is not going to be perfect, but maybe your first effort can grow and get better and make everybody happier at the very least. Did I answer your question appropriately? Oh.
No. The main point I was trying to make is one of the benefits of all these command line tools that are typically harder to use is that they can be composed in ways that the original writer did not intend. But with these web-based tools, like for internal processes, maybe one-offs, well, 10-offs, you wouldn't write this for like a one-off. It may be harder to compose them, maybe harder to put them together. Say you want to do this and then do something else if it's successful. Yeah, how did you combat that, or did the airplane crash and then you just said, I'll just clear the blast radius and then let them deal with it?
Yeah. So like, and that's an excellent point. Like composable Unix-like tools that are simple and just pipe into each other with standard in, standard air. Like those are something I use every day, and so I'm intimately familiar with those things. As a web developer, I'm also intimately familiar with taking one API, slamming it into another API, which goes into another API. And so that was kind of like the leap there, is that we treat our APIs suddenly like composable tools. Additionally, there's no reason why you can't have an API with a web GUI and then use a command line tool to call that API as well. And I would say that if you're going to build these tools, you should probably be pretty proficient at calling APIs as well. And there are some really nice ways to wrap that as well.
All right, guys, we're actually going to wrap it up here. We don't have any more time for questions, unfortunately, because we got to move into the open spaces part. So thanks again, Philip.
Absolutely. Thank you.
Thanks, man. All right. We are going to jump into open spaces. So how many people don't know how open spaces work? You better know how open space work. You were here yesterday, right? Yeah, all right. All right, so this time around, we we actually give the opportunity to actually reuse some of the topics from yesterday, because there were some great conversations there. But we do certainly want to encourage new topics as well. So please, if you've been thinking about them already, if you've been thinking about metrics, if you've been thinking about developer happiness, you've